Welcome to Grandad's Workshop again. Today we're going to talk about physical and chemical changes. Now, we've seen changes before, but some changes are very different from others. Some changes, it's very easy to get back the substance you start with. For instance, here I've just scraped some ice from my freezer. And what's going to happen is that ice is going to melt. Look, it's changing into water. The ice is changing into water, but it will be very easy to get the ice back. All I would have to do is put it back in the freezer. So that's what we call a physical change. Here's another physical change. I've got some paper here. Ignore the writing. I've got some paper here. Is it still paper? Of course it is. The paper hasn't changed. I've changed it in a physical way. It's still exactly the same substance. Just like the ice changes to water and you can change it back. Let's have a look at another physical change. Here's some tin, a piece of tin wire. I've got a blowtorch here. You switch my blowtorch on. And the tin wire melts. If you don't believe that's melted, let me just show you. There we go. It's melted. But if I take that away, what will happen is that the tin wire will turn back to a solid. So again, melting. It's a physical change. We've seen another one. Dissolving. Here's some ordinary water. Let's put some bicarbonate of soda into ordinary water. And again, we can see if we shake it up, we can dissolve it. It dissolves nicely in the water, but it's easy to get back, and we know how to get it back. We simply heat the water and the solid will come back, as we did like in the last session. Okay, so those are physical changes. Another physical change, what about this big lump of iron? Oh, fire. If I keep doing that, I get iron filings. And those are iron filings which are made exactly like that. By filing a piece of metal, I got my iron filings. So all of those are physical changes. There's a different sort of change in the world. It's called chemical change. And the thing about chemical change is you can't get back what you started with very easily at all. Let's have a look at a chemical change. This now in here is vinegar. It's white vinegar. I use white vinegar for pickling sometimes. And this white vinegar, I'm going to add some of my baking powder to it. Remember, in water it just dissolved. Let's have a look. Whoa! It's fizzing. That's a sign that something has really changed in a different way. Fizzing like that has a special name in chemistry. We call it effervescence. Effervescence is a good word to learn. Effervescence. It won't go on forever because eventually the vinegar will be used up and so on. But we now have two different things made. One was producing the bubbles. One thing was producing the bubbles, a gas. And I'll let you into a secret. That gas was called carbon dioxide. And now in there we have a new substance, and it has a complicated name which isn't important. Okay, so that's one chemical change. Let's look at another chemical change. This time, what about the paper that I changed physically. Let's change it chemically. Now you can see that's burning. Now producing heat, when things happen and heat is produced, that's often the sign, well, it is a sign of a chemical change. So there we have a chemical change happening. We've not got paper there any longer. We've got a little bit of paper, but where it's been burned, that's a new, different substance. Okay, so that's a different substance, and we've seen another chemical change. Of course, we can do the same thing with metals. So we just switch our torch on again and drop some iron filings into the flame, and whoa, let's put it that way so you can see it better. And that's essentially what a sparkler is. Iron filings stuck to a piece of iron wire makes a sparkler. So there we go. Another chemical change. The iron, after it's been through that process, isn't iron, and it's called iron oxide, because what's actually happening is the iron is changing. It's actually, we say, reacting with the oxygen in the air. Okay, let's have a look at, should we have a look at one last chemical change? We will. Okay, so what I need to do is I need to make up a solution of sodium bicarbonate again. So I'll just refresh this and put some water in here again so I can make a solution of sodium bicarbonate a second time. Now, I've got water here now. I've cleaned up, I've got water here. And I'm going to put in to the water, I'm going to dissolve some of that sodium bicarbonate. It won't fizz because it was in vinegar before when there was a chemical change, a chemical reaction. Right, that's just water in there, and that is sodium bicarbonate. I'm going to swirl it up and make sure it has dissolved. We'll come back in a couple of seconds, about a minute, when it's dissolved. I've made up my solution now of sodium bicarbonate. It's only sodium bicarbonate dissolved in water. It's a physical change. It's not really a chemical change, not a chemical change at all. And I've poured some into this little test tube. And it's in that little test tube so we can see it more clearly. That's just the solution from here that I've poured into the test tube. And now I'm going to add some of this. You've seen it before. It's called lime water. It's very easy to make at home. I can make it by heating a bit of chalk and then dissolving that in water, and it makes me lime water. I'm just going to add the lime water to the sodium bicarbonate and see what happens. Well, nothing happens straight away. Let's shake it up and see. Shake it up. It's not poisonous. I'm not worried about hurting myself. You don't normally do this with chemicals, but they're not dangerous chemicals at all. And I hope that what you can see is that has become very cloudy. And if I shake it more, shakety, 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 it will get more and more cloudy for a while. Now, what we can see there is actually a little bit of solid coming out of solution. That's called precipitation. And that solid, if I leave it, and I've left it, in this case for a while, you can see the solid has fallen to the bottom. Can you see the white solid at the bottom there? Can you see the white solid at the bottom of the test tube? The liquid's clear. So we've made a new solid, a totally different solid, and that is another sign of a chemical reaction. So what's the big difference? With physical changes, we just have the same stuff. Melting, boiling, tearing paper. With chemical changes, burning, precipitation, effervescence. When we get chemical changes, we get new substances. Just one last thing. This is a piece of charcoal. Charcoal, it's a bit dirty, this piece of charcoal, but charcoal is, it's pretty pure carbon. And I can set charcoal alight. You've seen this thousands and thousands of times on the barbecue, and it will begin to burn. Okay, charcoal's a lovely example because it allows us to very simply say what's actually happening when a piece of charcoal burns. Okay, and what I'm going to do, I'm going to write down what we call a formula for the chemical change when charcoal, which is called really carbon, when carbon burns. We'll do that now. Charcoal is a substance called carbon. And when anything burns, it's really combining with oxygen in the air. There's oxygen in the air all around us. And when you heat carbon up, it combines with oxygen, gives out heat, of course. We get lots of heat. And a new chemical substance is made called carbon dioxide. And what we have here is what we call a chemical equation. Carbon plus oxygen gives carbon dioxide. And I think that's enough for today. Bye.